All right, so question of the hour. Why are we getting this number? Why are we getting 646 rather than just getting a number between 5 and 0? Because our voltage, it has to lie somewhere between 5 and 0, right? So it has to do something with the pin that we used to take this reading for us. Pin A0 is an analog pin. So there are a few analog pins on the Arduino Uno. They range between A0 and A5, so there's 6 of them. And they give readings as a 10-bit number. So for those of you who don't know what a bit is, it's simply a 1 or a 0. And what the pin A0 is doing is it's giving us a number that are 10 ones or zeros. So the thing about bits is as you get larger and larger bit numbers, the amount of different numbers you can have with them grows very quickly. So for example, a single bit can only give us 2 different numbers, either a 1 or a 0. A 2-bit number can give us 4 different numbers, 4 different arrangements of 1 and 0. A 4-bit number can give us 16 different arrangements of 1s and 0s. So the question is, the 10-bit number that A0 is capable of giving us, how many different arrangements are there for that? Turns out there are 1,024. So that's why we're getting this reading of 646. It is capable of giving us 1,024 different numbers. As it turns out, it does this in a very strange way. Rather than just giving us 1 through 1,024, it gives us 0, between 0 and 1,023. So it's going to give us 0 if the voltage is 0, 1,023 if the voltage is 5, and some number in between if the voltage is in between. So clearly 646 is lying in between 5 and 0, which we do expect, but we would like to know more precisely, what is that voltage? So we're going to have to do a little bit more math to figure out where 646 lies on this line between 0 and 1023. So let's come up with something general. So if I have a 0, I would like to know what percentage A0 is of the total. I would like to know, how does A0 compare to 1023, which is the biggest voltage I can have, the biggest reading I can have. So I'm going to take A0, whatever that number is, and I'm going to divide it by 1023. So this should give us a number. Hey, A0 is this much of 1023. This percentage, this decimal. And then I'm going to multiply it by, that's a very ugly parentheses. I'm going to multiply it by my starting voltage, which is 5. And that should give us the actual voltage reading rather than just some strange number between 0 and 1023. It's pretty tempting to just plug this into a calculator, but I'm going to do one better. I'm going to try to program this into our Arduino code and then get the Arduino Uno to read us the actual voltage back. So let's give that a shot. All right, so here's where we left off. So we found that just giving analog pin 0 is not good enough to give us the actual voltage reading. We're going to need to do a little bit of legwork on our own in order to make sure that number is displayed as something we understand as just a voltage. So like I said before, it's going to take some math. So we should come over here to math operators, and we're going to get the division operator first. I'm going to plug in analog pin 0. Remember that we just decided that analog pin 0 should be divided by 1023 to give us the percentage of 5 volts that we are getting from that reading. Then that is going to have to be multiplied. So I'm actually going to put this entire thing inside a multiplication block, also from math operators. But all of that has to be multiplied by 5 because 5 was the voltage that we started with. All right, so here's the moment of truth. We're going to go ahead and upload this. All right, and then let's go to the serial monitor and see if this gives us something appropriate. Oh no, the voltage is 0. Oh boy. All right, so what did we do wrong? Analog pin 0. I remember now. All right. So we have made one of the common errors in programming. So these pink blocks here all represent integers. So that means numbers without decimal places. So because our this number here, analog pin 0, which we saw was about 646, is being divided by 1023, that result is somewhere in between 1 and 0. However, the computer and our Arduino does not know what to do if we say, well, both of these numbers don't have decimals in them. So clearly, when you divide the two together, they shouldn't have decimals in them. So that's my bad, although it's probably a good thing that we ran into that problem. So I'm going to put one of these blue blocks here instead, which itself is able to have decimals in it. I'm not going to put a decimal in 1023 because I don't have to, but just the fact that we're dividing this number by something that can have decimals in it, it should clear that up for us. I'm going to do the same thing over here, just to make sure we don't run into more problems. So now I'm allowing decimals to take place in both of these mathematical operations. So hopefully that helps us out. All right, moment of truth, yet again. Hey, there we go. Looks like our math was a little off at some point though, right? So 3.10, 3.11 volts rather than 3.4. So that can probably be caused by the tolerance in the resistors. So just because the resistor says that it's 10,000 volts, or I'm sorry, 10,000 ohms, doesn't necessarily mean it's 10,000 ohms. It probably lies very close to 10,000 ohms, within like 5% or so. And the same is true of the 4.7 thousand ohm resistor as well. So since they're off by a little bit, our reading is a bit off as well. But there you go, we finally got there. So we have this serial monitor reading the voltage to us as expected in a language, in terms that we can understand. All right, so that's been the voltage divider. I hope this all made sense to you. I'll see you guys in the next video.